The dawn of the 21st century has ushered in an era of rapid technological advancement, transforming the fabric of our daily lives and reshaping industries at an unprecedented pace. Emerging technologies, those on the brink of broad adoption, promise to further revolutionize the way we live, work, and interact with the world around us. From the marvels of artificial intelligence and quantum computing to the cutting-edge developments in biotechnology and renewable energy, these innovations hold the potential to solve some of the most pressing challenges of our time. Mojo Vision's prototype. Invisible computing refers to the availability of relevant information whenever needed without distraction. These lenses aim to provide digital information to the wearer's retina while being connected with the surroundings. Thus, the content is invisible from the user's visual field when it's not required. This technology claims to help users respond dynamically and access the data without the distraction of a gadget. Mojo Vision developed the first AR contact lenses aiming for invisible computing in 2020. This prototype featured only a single LED display and a wireless power system. The latest iteration of the device includes computer vision, augmented reality, a LED display, a broadband radio for communication, eye tracking sensors, a thin-film solid-state battery. Despite this extensive list of technology, the computing systems are not included in the lens. The company is developing a separate computing device called a relay. This wearable device, which users can wear around the neck, communicates with the lens and runs applications. It streams multimedia to the lenses and gathers sensor data from the eyes to track what information the user wants next. All of this communication states to occur with minimal latency. The latest prototype of the Mojo lens is the result of advanced, innovative technologies, ranging from displays to communication protocols. SpinLaunch. SpinLaunch is a spaceflight technology development company working on mass accelerator technology to move payloads to space. As of September 2022, the company has raised $150 million in funding, with investors including Kleiner Perkins, Google Ventures, and NASA. SpinLaunch is developing a kinetic energy space launch system that reduces dependency on traditional chemical rockets, with the goal of significantly lowering the cost of access to space while increasing launch frequency. The technology uses a vacuum-sealed centrifuge to spin a rocket and then hurl it to space at up to 4,700 miles per hour. If successful, the acceleration concept is projected to lower the cost of launches and to use much less power, with the price of a single space launch reduced by a factor of 20 to under $500,000. At Spaceport America in New Mexico on October 22, 2021, SpinLaunch conducted the first vertical test of their accelerator at 20% of its full power capacity, hurling a 10-foot-long passive projectile to an altitude of tens of thousands of feet. This test accelerator is 108 feet in diameter, which makes it a one-third scale of the operational system that is being designed. The company's first 10 test flights reached as much as 30,000 feet in altitude. A number of reasons why this technology may not work have been put forward, by whom including problems with massive spinning objects, potential for catastrophic damage to the payload, incompatibility with traditional liquid rocket fuels, and increased atmospheric drag relative to existing technologies. Graphene and graphene oxide. The use of graphene-based materials, such as graphene oxide, in biosensing applications is gaining significant interest due to high signal output, with strong potential for high industrial growth rate. Graphene's excellent conduction and mechanical properties, such as toughness and elasticity, coupled with high reactivity to chemical molecules, are some of its appealing properties. The presence of ripples on the surface, whether indigenous or induced, represents another property/variable that provide enormous potential if harnessed properly. Biosensors are tools that detect the presence and amount of a chemical substance, such as pregnancy tests and glucose monitoring devices. They are general portable, have short response times, and are sensitive, making them highly effective. Gold and silver are used in biosensors, and more recently, graphene. Graphene is sheets of carbon atoms, and is the only two-dimensional crystal in nature. It has unique features allowing its effective use in biosensing applications, including the presence of ripples, non-flat areas that give it its electronic properties. Graphene is highly successful in detecting chemical and biological substances like DNA, bacteria, lipids, peptides, viruses, antibodies, and ions. Moreover, graphene and graphene-based materials can immobilize different bioreceptors covalently or non-covalently, which make them excellent for biosensing applications. Single-stranded DNA can bind from its ring-structured nucleobases to the graphene surface by non-covalent interactions like stacking, hydrogen bond, and electrostatic interactions. Proteins can chemically attach to carboxylic groups of graphene oxide by their amine groups. GPS-3. GPS-3, the latest generation of global positioning system satellites, represents a significant leap forward in satellite navigation technology. Developed by Lockheed Martin and overseen by the United States Air Force, GPS-3 satellites are designed to provide enhanced accuracy, reliability, and security for both military and civilian users. These advanced satellites offer several key improvements over their predecessors, including 3 times better accuracy, up to 8 times improved anti-jamming capabilities, and a longer lifespan, ensuring more robust and dependable global positioning services. One of the standout features of GPS-3 is its compatibility with other global navigation satellite systems, such as the European Galileo system. This interoperability enhances the accuracy and reliability of positioning data worldwide. Additionally, the introduction of a new civilian signal, L1C, aims to improve civilian GPS use, offering more precise location data for applications ranging from smartphone navigation to emergency response. Smart floating farms. Smart floating farms represent a pioneering solution to address the growing global challenges of food security, urbanization, and climate change. These innovative agricultural systems are designed to float on water bodies, utilizing advanced technologies to create sustainable and efficient food production environments. Combining aquaculture, hydroponics, and renewable energy sources, smart floating farms offer a promising way to produce fresh food close to urban centers, reducing transportation costs and environmental impact. At the heart of smart floating farms is the integration of cutting-edge technology. Automated systems monitor and control water quality, nutrient levels, and environmental conditions, ensuring optimal growth conditions for both plants and fish. Solar panels and wind turbines provide renewable energy, making these farms self-sufficient and minimizing their carbon footprint. Additionally, the modular design of floating farms allows for scalability and flexibility, making it possible to deploy them in various locations, from coastal areas to inland water bodies. Edge computing. Edge computing is an innovative paradigm that brings computation and data storage closer to the location where it is needed, significantly enhancing the speed and efficiency of data processing. Unlike traditional cloud computing, which relies on centralized data centers, edge computing processes data at or near the source of data generation, such as local servers or smart devices. This approach minimizes latency, reduces bandwidth usage, and improves real-time data processing capabilities, making it ideal for applications that require immediate responsiveness. One of the primary drivers behind the adoption of edge computing is the exponential growth of Internet of Things, IoT, devices. These devices generate vast amounts of data that need to be processed quickly and efficiently. Self-healing concrete. Self-healing concrete is a groundbreaking innovation in the construction industry designed to address one of the most persistent issues in infrastructure maintenance, the deterioration and cracking of concrete over time. Traditional concrete, while strong and versatile, is prone to developing cracks due to environmental stressors, physical loads, and chemical reactions. These cracks can compromise the structural integrity of buildings, bridges, roads, and other infrastructures, leading to costly repairs and maintenance. The concept of self-healing concrete involves the incorporation of materials and technologies that enable the concrete to autonomously repair cracks as they form. This self-repair mechanism can be achieved through various methods, each leveraging different scientific principles. Microbial induction. One of the most promising methods involves the use of bacteria that produce limestone when exposed to water and oxygen. These bacteria, typically from the genus Bacillus, are embedded into the concrete mix along with their nutrient source, usually calcium lactate. When cracks form and water enters, the bacteria become active and precipitate calcium carbonate, limestone, which fills the cracks and restores the concrete's integrity. Hydrogen fuel cells. Hydrogen fuel cells represent a transformative technology in the quest for clean, sustainable energy solutions. These cells generate electricity through an electrochemical process that combines hydrogen and oxygen, producing only water and heat as byproducts. This makes hydrogen fuel cells an exceptionally clean energy source, with the potential to significantly reduce greenhouse gas emissions and dependence on fossil fuels. At the core of a hydrogen fuel cell is a stack of cells, each comprising an anode, a cathode, and an electrolyte membrane. The process works as follows. Hydrogen supply. Hydrogen gas, H2, is supplied to the anode side of the fuel cell. Electrochemical reaction. At the anode, hydrogen molecules are split into protons and electrons by a catalyst. The protons pass through the electrolyte membrane, while the electrons are directed through an external circuit, generating an electric current. The man-made stars changing the sky. The advent of artificial satellites and the ambitious megaconstellations being launched into orbit are transforming our night skies, introducing man-made stars that are both marvels of technology and sources of controversy. Megaconstellations consist of thousands of small satellites working together to provide continuous coverage over the Earth. SpaceX's Starlink, for example, aims to deploy up to 42,000 satellites, while other companies like Amazon's Project Kuiper and OneWeb have similar plans. These satellites are typically placed in low Earth orbit, ranging from 200 to 1,200 kilometers above the Earth, making them visible from the ground under certain conditions. Technological benefits. Global connectivity. One of the primary benefits of these man-made stars is the provision of high-speed internet access to remote and underserved regions, bridging the digital divide and fostering global communication. Enhanced GPS and Earth observation. These satellites improve GPS accuracy and offer better Earth observation capabilities, aiding in everything from climate monitoring to disaster response. GPT-3 powers. GPT is a groundbreaking language model developed by OpenAI that has demonstrated remarkable capabilities across a wide range of applications. As one of the most advanced AI models for natural language processing, GPT-3 has numerous powers that enable it to transform various domains, from creative writing and customer service to education and software development. Here are some of the key powers and applications of GPT-3. GPT-3 can generate coherent and contextually relevant text based on given prompts. This makes it useful for tasks like writing articles, creating marketing copy, drafting emails, and composing creative fiction. GPT-3 powers chatbots and virtual assistants that can engage in natural, human-like conversations. These agents can handle customer service inquiries, provide information, and assist users with various tasks. GPT-3 can translate text between multiple languages, aiding in communication and language learning. It can also generate language exercises and provide explanations for language learners. Thanks for watching. Subscribe for more content like this.